Welcome back to By the Numbers here on the College Guide. Today we are doing our first major spotlight, and I'm going to start with what I know. So we are going to be talking about chemical engineering today. So bear with me. I hope you guys are excited about this, and if not, you can at least see the kind of content I'm going to be going through as I move through all the different college majors. So please hit the like button if it's helpful. Subscribe to the channel if you're just waiting until I can get to your prospective college major to see what you might be interested in and what you're in for. Let's go ahead and just jump right into the data. So I got this initial data from the BLS, the Bureau of Labor Statistics. That's backwards with my hand. The Bureau of Labor Statistics, which is a governmental organization that keeps track of all of the workers in the US and what they do and how much they make and locations. So we're going to jump into that data. So the first thing is that according to the BLS, there's 26,300 chemical engineers, or jobs in chemical engineering rather, in the US in 2020. Now, there are lots of jobs that maybe don't fall under this umbrella that chemical engineers can fill, so you don't have to panic and say, what if there's 5,000 chemical engineers graduating every year? How am I going to get a job? There's lots of other options. This portion is very literal. It's if you want to go be exactly a chemical engineer and your job title is going to be chemical engineer, that's kind of what this data is. Later on, I am going to be going through the top 5 most common or most popular job titles for chemical engineers, so you'll get to see some of the variety that might show up here. Like I said, 26,300 jobs, and they expect 9% growth through the 2020s, so an additional 2,400 jobs, almost 10%. It would take them up to about 29,000 jobs almost. So there is growth there, and they said that this 9% growth is kind of what they expect. That's kind of average for their projections. So it's a good major. It's not a massively growing field, but you also don't have to worry about it going away. So now let's talk about where you might live as a chemical engineer. This picture right here is also from the BLS, and it shows the employment of chemical engineers by state. And what you can see from this is that the Gulf of Mexico, Texas, Louisiana is really heavily populated. California is also heavily populated by chemical engineers. And then you also actually see up in the Northeast, sort of, there is, or Midwest and Northeast. There are also a lot of chemical engineers in the Middle East if you want to go that route. But you see here, and that's because there's a lot of industry up there. A lot of chemical engineering has to go through pipelines or by boat. So anywhere that has a lot of water access is really good, as well as big metropolitan areas tend to have more because any place that a chemical engineer is going to work in a stereotypical sense needs a lot of people. It needs factory workers, it needs operators, it needs technicians, it needs maintenance people, it needs other kinds of engineers. They're very big facilities, and so therefore they're typically going to be in higher populated areas. This other picture over here shows where chemical engineers tend to be compared to other cities with chemical engineers. And so here we can see that, while on the other graph, California had a lot, compared to other jobs, chemical engineers are actually relatively rare, and compared to other places, chemical engineers are not as densely populated in California. We see that Texas and Louisiana still are very populated. The Gulf Coast is where a lot of refineries are. But you do also see that some of those Midwest states are not as populated, but more so. And again, it's because they have access to those resources, access to the transportation modes. And that's because chemical engineers are mostly in manufacturing and production type facilities. These two graphs are similar, but they break it down by metropolitan areas. And so you can see here that chemical engineers are pretty focused in cities for the reasons I mentioned earlier. You can see that even in places like Texas, there's a lot of wide open space where there might not be as many chemical engineering jobs. You see states like Utah, where I'm at, northern Utah has the jobs for chemical engineers. The rest of the state, not really. Even places like North Dakota, you see the west half of the state, that's probably where the oil fields are. The east half, not so much. And then focused on the eastern seaboard, along the Great Lakes region, and then the Gulf Coast, of course. And then as well, if you do the metro and compare them to other areas for chemical engineering, this is where you see that, that North Dakota, pretty high population of chemical engineers compared to other places like certain parts of Southern California, Kansas, certain parts of the Great Lakes region. And that's because the oil fields need a lot of chemical engineers as well, even though they're remote, whereas places like Houston or LA need a lot of chemical engineers, but they also just need a lot of stuff because there's a lot of people. The last image that I'm going to show is this here, and this is the annual mean wage of chemical engineers by state. We are going to get into more numbers, so don't strain your eyes trying to read those numbers on the chart there, but this does show the regional differences, and region also goes with industry a lot of times. So you see Texas, Louisiana, Oklahoma, natural gas and oil, Alaska, tons of oil, as well as being hazardous, so they pay you extra if you go work in Alaska. So that's where the chemical engineers get paid the most. You look at other places where there might be, like in Iowa, there's a lot of ethanol plants, so they get paid decent there. California, they get paid pretty well there, but that also could be because the cost of living is higher. A place like Utah, cost of living is average or a little bit below average. They don't have a ton of chemical engineering needs, and so the pay is a little less here in Utah compared to the rest of the country. And that's because we only have a very small amount of oil refining, and the rest is manufacturing, which tends to be not as lucrative for chemical engineers. And then as you look through the Great Lakes Midwest region, you see that they're a little on the lower side. Some of them, Illinois, Indiana, Ohio, they're lower than some of the other states up there. North Dakota, again, oil field pays well. So even though they live in the middle of nowhere where things don't cost very much in North Dakota, they get paid really well because they have crazy hours, they're living in the middle of nowhere, and oil fields can be hazardous in some ways. So now I want to get into those top 5 job titles that I talked about. The first one being process engineer, which process engineer is a job title I held as an intern. I was a process engineering intern when I worked at Valero. And right now I'm actually work in the process engineering group in my current job as a chemical engineer. And so this is very, very common, very, very typical. First thing, let's look at the salary. I got this salary data from Glassdoor, and I found the common job titles from Zippia.com. So if you want to do your own research before I make a video about your major, check out those 2 websites. But Glassdoor says a process engineer typically makes $96,745. Now, what I will say is a lot of these job titles probably come with a promotion. For example, right now, in a lot of engineering positions, you start out as an associate. And so I'm an associate process engineer. And so therefore your salary is quite a bit lower. So if we adjust that, lower it by 20 to 25%, an average process engineer salary is maybe about $72,500, which is a fantastic salary. And you'll be very well set. No matter where you're living, you'll be able to afford a place to live, afford your food, afford a car, afford insurance, all that kind of stuff. Very, very good, very competitive. And it's a great major for that reason. As far as what process engineers do, they help test and maintain equipment, they write procedures, they make sure that things are in accordance with standards for manufacturing, they might price out and purchase and design new systems, and they oversee the safety of the employees. We have a separate safety department, but in the end, safety is everybody's concern, and as the process engineer who is most familiar with all the ins and outs of a chemical or manufacturing process, safety is a #1 concern. You do also, as a process engineer, tend to push a lot of paperwork, and that's just because you'll be assigned to a specific process. You are over this manufacturing process, or you're over the crude refining unit or something, and so you're in charge of that, and so any changes, any procedural updates, they all have to go through you, which means you're doing the paperwork, you're signing it, you have to do a lot of meetings to verify checkout plans, whatever it might be. But you do get to do a lot of in-field work typically when it comes to being a process engineer. Common job title #2 is chemical engineer. No surprise there, it makes sense. If you are a chemical engineer, your job title could be chemical engineer. A little bit lower, and that might just be industry specific where people tend to be called this. So their salary on average, according to Glassdoor, was $88,772. And again, if we adjust that down for an entry-level position, it's at $66,500. So still competitive, still a great salary. And the responsibilities here are often quite the same. However, when you think of a chemical engineer specifically, they might be a little more associated with a lab, we'll say, or they're in the chemical producing industry or maybe the pharmaceutical industry. So rather than just being a generic process engineer, you have the title of chemical engineer. So that's probably just skewed towards specific industries. But the job responsibilities are very similar. The third one to talk about is manufacturing engineer. And again, this gets a little more broad because manufacturing engineering positions could probably be fulfilled in a lot of times by mechanical engineers, electrical engineers, manufacturing engineers, chemical engineers. So it's a little more broad, and with that breadth, there's a greater pool to pull from, so the pay is lower again. An average manufacturing engineer position is $79,000. If we adjust that down for an entry level, maybe a little above $59,000. Still a great salary, still competitive, but not as lucrative. And this also deals with the products. A lot of manufacturing operations, they're common commodities. They might be making shampoo or pencils or calculators or something that, there's lots of competition out there, and you have to be as efficient as possible to keep your bottom line low. And so therefore you aren't paid as much, because like oil and gas is a very lucrative industry. Making calculators or pencils, not quite so much. Manufacturing engineering does come with slightly different responsibilities as it pertains to specific processes maybe that you're working on. There's different connotations there. When I think of a manufacturing engineer, I definitely think of being out on like a factory floor where you're doing lots of physical processes. So you might be doing coating things, lining things. Maybe you're working with sheet metal products and you're bending or forming sheet metal. You're casting things, maybe plastic injection molding, things like that. Very physical processes, not so much liquids going through pipes and undergoing chemical reactions and gases and liquids and stuff like that, like you think about with a chemical plant or an oil refinery. They do also do a lot more maybe statistical analysis, a lot more testing, saying, okay, I'm going to take, 25 of our products and test them and see how many of them were good. What's our failure rate and things like that. So a little more statistics or statistical process control, a little more quality control involved where you're doing these tests and looking at the data. Again, still pretty typical, but maybe not quite as chemistry heavy. If you become a manufacturing engineer as a chemical engineer, you may not use your chemistry quite as much. Same as me. I personally don't use my chemistry a whole lot at my current job as a process/manufacturing engineer. Job title number 4 is project engineer. And similar to manufacturing engineer, this can be fulfilled by a lot of different engineering type backgrounds. And so again, that pay is a little bit lower relative. They say $79,485. If we adjust that for entry level, maybe $59.6, so almost $60,000 a year. And a project engineer is more, we'll say, project focused. A process engineer is on the day-to-day operations. Here's a specific process you're learning about. A project engineer is about, we're going to do this improvement. We need to put in a second train of this system. We have this, we want to duplicate it to double our throughput. Or maybe we need a backup safety system or an overload tank or something like that. And so your job is more focused on that small project and about pricing, how to keep your prices low, who's going to do the labor and how much is that going to cost, keeping things on schedule, calling your vendors saying, are our parts coming in when they're supposed to, making sure there are maintenance workers available, and making sure that all the proper paperwork and checkout is done when it's done, so you can turn it over to the process engineer and say, this is a functioning, safe, and operable piece of equipment. Start using it in your process. So if you want to be a little more on the design side of things, project engineer would be a great job title for you, rather than day-to-day operations and sort of keeping the status quo and making minor improvements. Job title number 5 that I want to talk about today for chemical engineers is quality engineer. This one is kind of in that same boat that it could be fulfilled from a lot of backgrounds. So the salary is $80,779, adjusted for entry level, maybe $60,500, $60,600 around there. So you're kind of seeing what the family is of what chemical engineers make. And quality engineers, they take that part that makes a manufacturing engineer different from a process engineer, and that is their whole job and focus. They're testing materials that are coming in. They're testing products that are going out. They're looking at failure rates, that they fit all the specs, that they fit safety standards and national standards for whatever product you're making. And so they get to be very hands-on with the product, which in my position as a process engineer, a process controls engineer, I interact with the process, but I don't go and feel and touch the rocket motors we're producing and look at them when they're done. I kind of see them for one little part of the process, and that's it. So if you really want to be hands-on and see completed products, being a quality engineer could be a really great option for you. If we look at these 5 jobs and average them, the pay would be $84,969, so almost $85,000. Adjust that down for entry level, about $64,000. And when I was first looking for my job out of college, I do remember seeing that the national average for chemical engineers was about 65,000. So that's a good number to keep in your head as far as what they make if you're trying to decide if it will sustain the kind of lifestyle that you want. All right, break time. Did you know that your eyes are the last part of your body to die? Yeah, when you die, your pupils dilate. If you like that pun, or this video has helped you get a clearer picture of what your career might be, please like this video and subscribe to the channel, especially because later this week there will be a video of an interview with a chemical engineer where you can get all the scoop from them. All right, back to it. I do want to go through just a few more demographic type information statistics about chemical engineers. Again, these came from Zippia, and I believe that they're dated back maybe to 2018 or 2019, so keep in mind things may have shifted a little, but they give you a general idea. The first thing is that chemical engineering, like most engineering fields, is skewed very male. It's only about 25% of chemical engineers that are female. However, at least in school, chemical engineering actually had a higher percentage of females than the other engineering disciplines. So if you're a girl who would like to go into engineering, this might be a place where you have a few more people that are like you, a few more girls in the major that you could study with or talk with or commiserate with. A lot of this, I believe, is because, in my experience, they were usually headed towards the health field, the biomedical field, or maybe to grad school, tended to be the goal, or maybe environmental issues, whereas guys in chemical engineering oftentimes were a lot more about whatever pays the most, oil and gas, or things that explode. I fall in that things that explode category now. It's just the way it is. The average age of a chemical engineer is 40, and you kind of expect that, right? The workforce was about from 25 to 65 or 70, so 40 is kind of in the middle. But chemical engineering, I do see that is sort of cyclical, not just in the oil industry, but across industries. For example, in aerospace and defense, we hired a ton, and then you have to do some layoffs and hire a ton and do some layoffs because programs come and go. You know, when the shuttle program was going, you need a lot of people to support that. When the shuttle program gets shut down, don't quite have as much capacity. So at my plant, there are a lot of engineers who are in their early to mid 60s who will be retiring in the next 5 years. There's a smaller group who has about 15 to 20 years of experience. And then there's a bunch of brand new chemical engineers. So now is a good time to get into it because you can facilitate that knowledge transfer. And then there's a lot of vacuum at the top, all these people at the top leaving, and you rise with it. As far as racial demographics, chemical engineers, 70% of them are Caucasian, 30% minority. So again, a little bit skewed there, not totally equal representation, but also not uncharacteristic of the US either. Pay-wise, women earn 96% of what men earn, according to Zippia, which, you know, not the greatest, but not the kind of statistics that you hear about that people are fighting against. I would almost say 96% is within statistical reason, higher or lower, but there is a slight pay difference there if you want to be aware of that. 78% of chemical engineers have a bachelor's degree, so this is a great career if you just want to get a bachelor's and go. That was part of the reason I chose it, because I knew engineering in general and chemical engineering, I could get my bachelor's degree and head right out of school and go get a job. The last thing I want to talk about is unemployment, and their data showed that it's been under 4% for about the last decade. This doesn't include COVID. I wish I had data to share with you about how chemical engineers fared through COVID, but in my experience, all my friends were able to find jobs, even though we graduated in April of 2020, right when everything was shutting down. I had one friend who it took about 6 months. I had a couple of friends go to grad school, and the rest of us had jobs within 6 weeks of graduation, if not lined up way before graduation. So people always need engineers. People always need chemical engineers. It's a great place to take your career. Hopefully this gave you a lot of good information. If there's any questions you had about chemical engineering or about a major in general that you would like me to make sure and address in future videos, let me know so I can make this video better for you guys. I'm a chemical engineer. I already know what I need to know about chemical engineering, but I want to share everything I can, either through research or personal experience, so that you can make informed decisions about your college major. Thanks for tuning in to this episode of By the Numbers. We'll see you next time.